introduction. Uh, Thanks a lot for this opportunity. Welcome to my talk on NLP methods to interpret political polarization in news media and user responses. Uh, Before I talk in detail about the two papers I'll be covering, I want to give a quick snapshot of my research program. My research program has three interconnected strands. In the first strand, I work on the US political landscape. And there, my focus is both on the methods and also on the substantive side. So for methods, I seek to build robust methods to quantify political polarization and echo chambers. And on the substantive side, I have worked on important hot button issues like US policing or the Capitol riot. In the second strand, I focus on international politics, mainly globally important events in Southeast Asia. I have worked on the 2019 India-Pakistan conflict and Rohingya refugee crisis, where mainly the focus is to build novel framework to counterbalance hate with positive content, and also to democratize natural language processing through building low resource natural language processing methods. I've also worked on the 2019 Indian election and water crisis. And there the focus is to aggregate opinion from unstructured text data. Finally, in my third research strand, I work on minority-aware responsible AI. In a recent project involving 70 years of popular Bollywood and Hollywood movies, we found that Bollywood has a strong bias towards associating beauty with fair skin complexion, and there is a strong sun preference. And in another work, which Sisi was just mentioning, we found that if we use automated speech recognition systems and apply it to kids' videos, they actually create very unsafe error. For example, here the kid is saying that you should also find corn, and the ASR system is saying you should also find porn. And when this work got acknowledged by international media, the best part of the whole thing was some of these high-risk errors were fixed by YouTube. So now if you go and check that video, you will see that Ryan is actually saying you should buy corn, and that's correctly transcribed. So that's my broad research program. So today I'll be talking about two interconnected papers. In the first one, I'll be talking about political and ideological biases in social media data. And in the second part, I'll talk about disparate media portrayal of policing in the US. So here goes the first part, quantifying polarization on large-scale discussion data sets, discussing a multitude of issues. This work is focused on the US political landscape with a key emphasis on the 2020 election buildup. However, much before that, if we look at this Pew Research survey spanning 20 years, where registered Republicans and registered Democrats were asked policy-related questions, if you see that as time progressed, the response of the registered Democrats, they have become more and more liberal, and the response of the registered Republicans, they have become more and more conservative. The role of hyper-partisan news media behind this deepening political divide is well documented, and there is extensive literature outlining the partisan and ideological divergence in both content and audience. In this work, we focus on four major US cable news networks: Fox, CNN, MSNBC, and One America News. Of these four, the big three are MSNBC and Fox and CNN. We consider their YouTube channels, and you can see that they have substantial presence on YouTube with millions of subscribers. We also include One America News Network. It didn't have that many subscribers as compared to the big three, but it had a very strong champion in the form of the former president. So here is how the information is flowing. This is everything that's going on in the universe. And then a subset of that are events interesting to United States. Then different subsets, assuming they have substantial overlap, are of interest to these different news networks. Then these news networks cover these events, and their news videos reach out to a broad and diverse audience, again, assuming that these audience subsets have overlap. And once they watch these news videos, they comment on them. So our final data set is a very rich and novel data set of user comments on news videos. And we have gathered a data set of more than 85 million comments posted on more than 200K news videos over the last 6 years. Now, intuitively, we kind of know that Fox discussion or MSNBC news discussion will be different. But how do we quantify the differences between these large-scale social media discussion data sets discussing so many different issues? Polarization has been widely studied in social science. A seminal line of work from Keith Poole's research group and his co-authors were talking about how to use congressional votes to measure polarization. There has been extensive literature in computational linguistics and in network literature. But here we are dealing with a completely different challenge of quantifying political polarization on large-scale discussion data sets, discussing multitude of issues. And this was like an open NLP challenge that we addressed in this paper. Before I describe our methods, we need to take a quick detour of how machine translation works so that we will be able to understand and appreciate this work better. So when we say that two words are close to each other, what do we mean by that? Let's say the words close to car. There are 3 columns of words, the red, blue, and black. Of these 3, do we think that the red column, these words are close to car? I think I'll say yes, because vehicles and cars are, of course, like car, truck and ambulance, a specific type of car. Bike, not so much car, but I can still use it to go from point A to point B. How about the blue column? Do you think it's related to car? Again, I'll say yes, it's related to car because I have seen these words co-occurring with the word car in a sentence. So the idea is, and what about the black column? No, right? So we all kind of intuitively know what do we mean by 2 words being close to each other. And the justification is words are close if they appear in similar contexts. And the context can be shared in 2 different ways. Words that are near synonyms. For example, I went for a car ride. You can just replace car with bike, and you will still have a sentence that makes reasonable sense. And that way, car and bike will be sharing context. Words that are other related word, they actually appear in co-occur in similar sentences, and that's how they share context. For example, I was driving my car. So in 2013, a breakthrough result came from a group of researchers who developed methods to process vast amount of text and place individual words in a high-dimensional space such that each word is assigned a point in this high-dimensional space, and the distances between the words in this space, that captures the notion of closeness. And the technical term of this is word embeddings. Now, I cannot show a 100-dimensional word embedding on a PowerPoint slide. So here is a 2-dimensional representation. of two word embeddings. On the left side, we have some numbers and animals on an English word embedding. And on the right side, we have the same numbers and same animals, but in Spanish on a Spanish word embedding. Now, if we look at these two word embeddings, we kind of see that there is some isomorphism in the structure. And if we can learn a linkage function so that if we take the coordinates of horse and multiply with this linkage function and get the coordinates of caballo, which is the translation of Spanish translation of horse, and if the same transformation can be applied to other words, say we take the coordinates of cat and multiply with the same transformation and we get gato, we are able to align the two word embeddings and we are able to perform single word translation. So essentially, word translation using machine learning works this way. We have word embeddings of two monolingual corpora of two different languages. Say if we are trying to translate English into Spanish, then L source is English and L target is Spanish. And then we will need some point pairs so that we know how to connect one embedding with another one. Okay. So suppose we have this set of words like hello maps to hola, fish maps to pescado, thanks maps to gracias. Then we know from these points, how can we learn the transformation W so that when we have the embedding of the source word, we multiply it with W and we can go to the other embedding space and get the target word. So formally, let L source and L target be two languages with vocabularies V source and V target. And then the translation scheme from language of source to language of target, it computes a transformation W that and takes a word W source belonging to the source vocabulary as input and outputs a single word translation W target such that the target word belongs to the target vocabulary. And of all the words in the target vocabulary, when we multiply the transformation with the embedding of the source word, whatever the resulting value that we get, it's closest to the target word within the target vocabulary. And cosine distance is used as a measure for distance. All right, so we are now ready to describe how we quantify polarization between these news discussions. So again, it will be easier if we take two news networks as examples, say CNN and Fox. We assume that the two subcommunities are speaking in two different languages, language of CNN and language of Fox. And then we try to translate each word belonging to language of CNN into language of Fox. Now, if you try to wrap your head around this thought, I mean, it's kind of weird. I mean, even if you think about, say, trying to translate British English into US English, then there will be certain words like flat that will translate into apartment in US English. But when we think about translating US English to US English, what does even that mean? I mean, ideally, in a world not fraught with polarization, apple, tree, words like this should map to apple and tree in language of Fox. Here, however, we focus on word pairs that do not translate into themselves, and we call them misaligned pairs. When misaligned pairs appear in similar contexts, they often signal political and ideological disagreements. So here at the left side are comments on CNN news videos, and the right side are comments on Fox News videos. You can see that the two words Republicans and Democrats, they appear in mirroring contexts. Republicans are the greatest threat to America. Democrats are the greatest threat to America. Republicans are traitors. Democrats are traitors. I'll never vote Republican again. I'll never vote Democrat again. So no wonder why a machine translation method who has no clue about what is Republican, what is Democrat, it will think that Republicans in CNN English translates into Democrats in Fox English, and Democrats in CNN English translates into Republicans in Fox English. So Our process is quite simple. Again, say we have Fox and CNN, we have two sets of word embedding. Remember that we needed a bilingual lexicon, like a pair of words, so that we can connect the two word embeddings, like fish, pescado, hello, hola. This time we are working with translating English into English. So the way we construct this bilingual lexicon is by assuming that no matter how polarized we are, all the stop words like and, or, about, they map to themselves. So no matter how polarized CNN and Fox are, and in CNN English still maps to and in Fox English. About in CNN English still maps to about in Fox English. So then we have these two sets of word embeddings. We have points of CNN word embedding like and, or, about, and we exactly know that they map to the points of and, or, about in the Fox word embedding. And then we try to align them using a machine translation method to compute the transformation. And eventually the philosophical idea is, if two communities are ideologically very different, then there will be many mistranslations. And if two communities are speaking nearly roughly the same language, there will be fewer mistranslations. So we can just compute the percentage of words that translate to itself, and that gives us an agreement value between the two communities. So essentially the similarity between two languages, language of source and language of target, is just counting how many words translate to themselves. And higher this value, the closer these two communities are. So before I talk about the quantitative aspect of our results, the qualitative results are also very interesting. So these are some of the misaligned pairs when we try to translate language of CNN into language of Fox. So remember that all of these words should have mapped to themselves, but they did not. So if we look at this misaligned pair in the political entities section, we see that Dem Republican, GOP Democrats, like these are some usual suspects. But we see a misaligned pair, Kushner-Burisma. So Kushner is the son-in-law of former President Trump, and Burisma is the oil company with which Hunter Biden, the son of the current president, ran into some allegations. So you can see that there is a hint of nepotism present in this misaligned pair. If we look at the derogatory misaligned pairs, we have Trump-tards and snowflakes. So Trump-tards is a derogatory term for all the Trump supporters. Snowflakes are the derogatory terms used by the Trump supporters against the liberals. And you see that they're forming a misaligned pair. In the ideological section, we have the usual suspects like liberalism, conservatism, liberals, conservatives. But one misaligned pair left us completely shocked. KKK BLM, and we were like really shocked to even think that is this even happening for real. And we took a closer look at the data set. Again, the left side are the comments on CNN news videos, and the right side are comments on Fox News videos. And you can see that indeed KKK and BLM, they did appear in mirroring context across these two news networks. So this shocking result received a lot of media attention, and rightly so. And the fact that the left and right, they speak so differently that machine translation methods that were actually devised to translate English into Spanish or Spanish into German, like truly different languages, those methods can be used to quantify polarization. That also received quite a bit of attention. So now we can move to the quantitative side of the results. This is a 3x3 matrix where for each cell, we report how similar these two news networks are. And higher the value, the more the similarity. So if we look at the top row, we see that CNN is closer to MSNBC than Fox. The second row tells us that Fox is closer to CNN than MSNBC. And The final one tells us that MSNBC is closer to CNN than Fox. So if we combine these three nuggets of information and place MSNBC on the left, then a logical assignment is MSNBC, then CNN, and then Fox, which also aligns with our real world knowledge. But I'm actually ashamed to admit that news is not the only source from where we get our political knowledge and information. I am actually a big consumer of political comedians, primetime comedies. And we constructed another data set where we constructed comments on YouTube videos of all these political comedians. And we wanted to know that to which news language this political comedian viewers' language is similar to. Any idea? Yeah, it's actually somewhere in between MSNBC and CNN, and it's farthest from Fox, which again like aligns to what we kind of guessed. But on a much more serious note, we investigated the Capitol riot, and we constructed a data set of former President Trump's YouTube followers, I mean, like their comments on Trump's official YouTube channel. And we looked into three conservative networks, One American News, Newsmax, and Blaze, along with the three mainstream media networks. And we found that language of Trump followers is closest to language of Newsmax, followed by language of One American News, and then Blaze, Fox, CNN, and MSNBC. And if we recall, then we will know that Newsmax and One American News were the two news networks which were airing maximum news items on unsubstantiated voter fraud claims. So when we have a data set of like 85 million comments, it's not feasible for us to read individual comments to understand the differences between the communities. But the moment I tell you that solar in language of CNN translates into fossil in language of Fox, we immediately know that there is a debate surrounding energy sources. If I tell you mask in language of Fox translates to muzzle in language of One American News, we immediately know that there is a debate surrounding how mask is interfering with freedom of expression, and there is a sub-community that does not feel very positive about wearing masks. We also tried to move beyond single word, and again found a very shocking and disturbing result that Black Lives Matter in language of CNN is closer to All Lives Matter of language of Fox than Black Lives Matter. So what it shows that our method can shed light into this kind of deepening political divide, and in a very interpretable and quantifiable manner. We also did a follow-on research work on examining the 2019 South American protest. And there we were dealing with Spanish Twitter. And we found that there also we could find misaligned pairs like comunismo, fascismo, socialista, capitalista, indicating that this method can translate to different language, different social media, and also different political crises. So the socio-linguistic impact of this work is different words may be used in near identical contexts in different communities, and such words may inform us about fundamental differences between the communities. And machine translation methods provide a powerful, interpretable, and quantifiable framework. And to the best of our knowledge, this is the first work that connects the machine translation literature with the literature of polarization. So in the first part of the talk, I focused on a specific method and how to quantify polarization when lots of different issue-based discussions are happening. In the second part, we focus on a specific one, media portrayal of policing in the US. And in the last few years, three momentous events on policing in the US happened: George Floyd's murder, protest and civil unrest, the Capitol riot, and Derek Chauvin's conviction and sentencing. In this particular work, we look into three major US cable news networks, Fox, CNN, and MSNBC. As I already said, that their partisan and ideological divergence is very well documented. For example, 93% of Republican-leaning audience prefer Fox News as source of political news, and 79% and 95% Democrats prefer CNN and MSNBC respectively. So these three seminal events provide a natural experiment for testing how do these media outlets react to and report on these major policing events. And in this work, we give a demonstration of how advanced NLP technologies can help policymakers, content producers, and general public better understand the political disparity and partisan divide in the content creation of major media outlets. So our data is nearly 120K sentences with the keyword police taken from around 34K news transcripts between May 25, 2019 to July 24, 2021. So notice that last time we were working with comments on news videos. This time we are looking at the actual source and we are looking at the news transcripts. So we divide this 26-month time period into 4 non-overlapping slices. Time of pre-Floyd is 1 year prior to George Floyd's tragic murder. Then time of Floyd is from May 25th, 2020 to December 31st, 2020. T capital is the time between Jan 1st, 2021 to March 7th. And then T trial is Derek Chauvin's trial, which starts on March 8, 2021, and 1 month after his sentencing, ending on July 24, 2021. And the research question is, how did the aggregate stance of these 3 news outlets toward police evolve over time? Now, if we take a closer look at the data, say unarmed Black person committing no crime, shot and killed by police from MSNBC. Number one, it's a media activist class that took a tragic incident and cast all police as corrupt, which caused the Ferguson effect from Fox. And we have all seen the image of the Capitol police officer who led that mob away from the Senate chamber from CNN. We can see that there is a systemic difference between how police is portrayed in all these 3 news outlets. But human biases on contentious social issues are well documented. Then how can we quantify these differences using automated methods? I mean, this is a data science seminar, so I'm pretty sure everyone will know what is classification, but I give this seminar as a broad talk to many audiences. So here, a quick recap of how classification works. So classification is a predictive modeling problem where input is an example and output is a class label. So for example, predicting if a given example email is spam or not spam, or predicting if a given social media post is hate speech or not hate speech, or predicting if a picture contains a cat or a dog. So these all could be classification tasks. So in a typical classification setting, we want to train a machine learning model on a set of input examples. That's the training set. And the trained model is tested on an unseen set of examples. That's the test set. And then the model performance is measured by the prediction accuracy. There are other possible performance metrics also, but prediction accuracy is often used as a measure of a model performance. Now, typically, classification is treated as like an end goal. Like you want to learn some particular concept and you want to develop a model for that. But if we look at classification accuracy, that can actually tell us how distinguishable the different classes are. Suppose if we go back to the spam or not spam example, and the email is like the king of Nigeria is willing to send me $10 million, and all that I have to do is to just send 10K back so that the transaction process can be started. I mean, I always wonder that why don't they send me 9,990K, keep that 10K and start that process by themselves. But if the spam email is like that, you will be immediately able to identify spam from not spam. But if the spam email is very beautifully disguised and looks like a real email, then the classification accuracy will drop and it will be harder to classify. So intuitively, a low prediction accuracy may indicate the underlying class labels are hard to distinguish from each other. And then what we try to do is we have sentences from CNN and Fox, and with the class labels CNN and Fox, and we try to train classifiers to figure out if it is easy for a machine learning model to tell apart if this is coming from CNN or if it's coming from Fox. So basically, we are trying to do this pairwise classification to figure out if the portrayal of policing is different from these news networks. And we will need some kind of control group. The control group is you take any sentences without police and you try to see if you can predict the news network, like if it's coming from CNN or Fox. Then by comparing the classification accuracy of the control group with the classification accuracy of sentences with police, if there is a large difference, then we will be able to conclude that the news network in general, they cover news in very comparable way, but whenever it comes down to hot button issue involving police, their portrayal is very different. So that's the goal of this table. So what it does is in the top row, we have the classification accuracy between say Fox and CNN when we only focus on police related sentences. You see that between CNN and Fox, the classification accuracy is close to 75%. But between MSNBC and CNN, the classification accuracy is much lower. Correct? But when we focus on the bottom row, which is any random sentence, we see that all of the classification accuracy is around 60%, which means that their broad description of any other issue, those are not very different. But whenever it comes to policing, then CNN and Fox or MSNBC and Fox are very different and easy to distinguish, but CNN and MSNBC are not easy to distinguish from each other. So the key takeaway of this experiment is automated methods distinguish police-related sentences from CNN or MSNBC police-related sentences with much higher accuracy than distinguish between CNN and MSNBC. And no such noticeable pattern exists in the control group. So whenever we take random sentences, nothing changes. So, and Fox reporting on policing is considerably different than CNN and MSNBC reporting on policing. That's the final conclusion. So now these are some example high prediction examples from MSNBC, CNN, and Fox. And if you read the sentences, you will see that what I'm saying, that they do cover the events differently. So now we have established that Fox, CNN, and MSNBC, their police portrayal is different. But what we are yet to know is how does the support for police evolve over time, depending on each of the events. So that is the final research question, that how did the aggregate stance of these three news outlets towards police evolve over time? So here we used a framework of text entailment, which is essentially we have a pair of text, a premise and hypothesis. And the goal is to predict if in a world where the premise is true, if the hypothesis is also true, or if the hypothesis contradicts the premise, or if the hypothesis and the premise are unrelated. So there could be three possible output: entailment, contradiction, and neutral. So for example, if the hypothesis is some men are playing a sport, and the premise is a soccer game with multiple males playing, this is an example of entailment, right? Because if in a world where the premise holds, the hypothesis is also true. If we have a different premise hypothesis pair, as a black race car starts up in front of a crowd of people, and the hypothesis is a man is driving down a lonely road, we can say that this is contradiction, because in a world where the premise holds, the hypothesis is not true. So we can treat the same thing as uh, uh, as the entailment framework and use two hypotheses: police protect us and police make us safe, and then use each of these news transcripts, police related sentences as premise, and we can compute how many of those sentences actually satisfy the hypothesis. So for example, if the hypothesis is police protect us and the premise is, but we have nice police officers, black, white, Hispanic, that have taken care of this city, then we can say that this premise entails the hypothesis. But if we have, say, and in Minnesota, former police officer Derek Chauvin is sentenced tomorrow for the murder of George Floyd, we know that this does not entail, it actually contradicts police protect us. Finally, if we have something that is completely unrelated, like he's a former police officer is the premise, we don't even know if the hypothesis holds or doesn't hold, then the output is neutral. So entailment ratio is essentially for a given period of time, the denominator is number of sentences of police within that time period, and the numerator is the number of sentences that entail police protect us. So that means if this value is high, then the network has a very positive stance towards police during that particular time period. And if that value is low, then that means the support for police for that network is low at that particular point of time. And what we did was, higher value of entailment ratio indicates better support. So in this experiment, we used an off-the-shelf text entailment framework, and we fine-tuned with additional 1976 police-related sentences. We used a lot of different sampling methods to create this 1976 police-related sentences data set. And one sampling technique was, suppose you have a premise, you know for sure it cannot entail both police protect us and police do not protect us. Again, the same sentence cannot contradict both police protect us, police do not protect us, because the two hypotheses are negations of each other. One, the same premise cannot contradict both or entail both. So we actually run experiments and found which sentences are actually contradicting both the hypothesis and the negation. And we know for sure some inaccuracy has happened, and we label those examples to create a part of these 1976 labeled examples. So that sampling method is introduced in this paper. It's called inconsistency sampling. So here is the final result. These are the relative support for the 3 news networks during these 4 time periods. So when we look at the time of pre-Floyd, we see that the support for all 3 news networks, they were roughly the same. During the time period of Floyd, we see that that's the time when the BLM protests are happening. We see the support for police has significantly gone up for Fox, and the support for police has significantly reduced for CNN and MSNBC. During the Capitol riot period, we noticed that the support for Fox has not changed at all, but the support for police have dramatically increased for both CNN and MSNBC. And finally, during the Chauvin's trial, we noticed that the support for Fox reaches its support for police in Fox reaches its maximum during the Chauvin trial, and both CNN and MSNBC support gets reduced. So what are the key takeaways from this work is Fox's support for police substantially increased during the time of Floyd and trial, with time of trial showing maximum support. In contrast, CNN and MSNBC support considerably decreased during time of Floyd and time of trial, and reached their respective maximums during time of Capitol. And the substantive main finding is across cable networks, coverage of politically salient events responds quickly and dramatically to the partisan preferences of their viewership. So for future research, we can look at replication for other controversial issues such as abortion, gun control, and immigration. We can also analyze the audience commentary on reporting. And Interesting questions like, do network affiliates report differentially depending on their local political affiliation? If we look at Boston and Dallas and look at their MSNBC networks, are they going to report the same event differentially? So this work is done in collaboration with Tom. Tom is my mentor. Mark is a political scientist with whom I am offering the CMU RIT course right now. Baby is a professor from CMU, and Daniel Negin is a criminologist from CMU. Rupak is my former student who is right now doing PhD at University of Maryland. And Shujan is sitting there. Shujan is my current PhD student, and this is the first paper with Shujan. And I'm happy to take any questions. Thank you. Yes.